right? Because it is. Let's get into it. So this is me. My name is Steve Poole. I work for a company called Sonatype, which is not on there, which does software security, supply chain security. We run Maven Central and a bunch of other stuff. And that gives me access to a bunch of data about code. And from that code, from that insight, we're going, there's some things we should be sharing, or things I wanted to share about code. Right? And when I submitted this talk, I had an idea of what I wanted to cover. But as we started digging into the code, my idea of what the talk was supposed to be has changed. So it's not exactly as described, but hopefully you'll get some value out of it anyway. Right, so this is me. I've been doing Java since it was knee-high. I mean, I started working on Java before it was one at IBM, and I've done JVM stuff, everything you can imagine at JVMs, and security and DevOps. So I've been around, as you can tell, but my heart is always in the Java space, and it always will be. A plug, I have some stickers. With help of the Fujay guys, we're crowdsourcing a book about how to be a better developer, how to be a 10x developer. If you're interested in participating, go to the website and raise an issue about things you would be interested in, and whether or not that's fine. I have hand-cut stickers. You're welcome to use them. Right. So let's get going. How do you start thinking about API design? Right. When you're writing code, what's the first thing that you think about? Well, it comes down to how you're educated. And for most of us, we're probably not that well educated in this. Many of you will have heard of Solid. Yeah. So Solid is this wonderful list of arcane descriptions of how to write code. And it's very old school object oriented. There's some good advice in there for sure. But actually when you deal into it, you go, yeah, okay, makes sense. But it certainly comes from an older view of how you write code. It comes from an older object orientated space. And Java has evolved its thinking about what OO is as much as OO has evolved as well. So we're not going to talk about Solid, right? We are going to touch on this thing. Anybody heard of SEMVer, semantic versioning? Yes? Okay. Right, so this is where you have 3 parts to a version number, which I'm sure, you know, if you've downloaded code, you've seen. There's the simplest one, the patch. So if you have 101 and you move to 102, you're implying that you fixed some functionality, but nothing else has changed. You know, you fixed a bug. If you have 10 and you move to 1.1, you're probably saying I've added some publicly accessible functionality, right? And then if you change the major version number, then you're usually saying, look, I've broken something, you know, I have changed something, and unfortunately you've got to pick up the pieces, right? That sort of idea, okay? So, taking the history that we have and taking this view of sort of how we think we should police ourselves, how well do these ideas work in practice? Okay, so this is as I said, this is the peculiarity. So I go to Maven Central, we go look at all the data, and we say, let's analyze all the data and look at how good people are at keeping that promise. So do you think people are very good at keeping their promise or not good enough? Okay, well, it's really scary. So Maven Central says, and I haven't put the labels because it doesn't matter, that basically all of those version points can, when somebody changes it and declares that they've released a new version and picks either a major version or a minor version or a patch, most of the time there's likely to be a breaking change. So you can expect, obviously, major versions to be a reason for breaking, but unfortunately, quite often people break you for minor reasons or even for patch reasons, right? So that idea of you downloading something from Maven Central and feeling confident about the impact based on the version number Well, we didn't test everything, that's for sure. But on the ones we did look at, and some fairly important ones, it turns out, hey, we're really shit at this, right? Okay, so what I want to talk about is why that is, look at some of the reasons why this happened and explore that, and then look a little bit about what we could do to improve things, right? And there are some good techniques out there, and they're not particularly complicated to get your head around, okay? So what causes us to break things? Let's go through these things, right? Inadvertent changes, that's quite common. That's where you made a change and you didn't realize it was going to break something. You made changes that you thought weren't going to break things, you know, but it didn't work out quite how you wanted. And then there's the deliberate stuff, those people who sign up to move fast and break things, who go, it's not my problem that you're broken, it's your problem, right? And then the common one, the thing that you're probably all going to recognize is you made some wrong decisions. You didn't know they were wrong decisions, design changes, now you've got to deal with it. So what are we going to do? Okay. So a lot of the initial confusion about what breaks and what doesn't break is about understanding the differences between compile time, when you compile code, and runtime, when you run it, okay? They're different. So at compile time, you have your build place at the top. There's your dependency, the thing that you're going to consume, somebody else's code, and they have code and they compile it and they produce binary class files. And then in your code, you have source code, you compile it, you use their binaries, you spit out your own binaries, okay? That's fine. That's at compile time. Now at runtime, your code is deployed to the JVM, and there are different rules in place. So look, here we have class files version 1, class files version 2, dependency user code. A lot of where things break is when you have this model where you've updated a dependency and you haven't recompiled your code. Because why should you? Right? Unfortunately, as you'll see, there are these big differences between compilation and runtime. Well, not big differences, but enough to bite you. So I'm going to ask you some questions, right? Oh, the images all come from ChatGPT, of course, because why not? Okay, it's quite fun using it. Right, so let's ask you some questions. I have a version, two versions of the same class, right? It's a public class, and the second version makes it private. Right, and there are two cases, runtime and compile time. So the question is, can you reduce the access level of a method? And if you do, because obviously you can, what are the consequences? Will it work at runtime? Will it work at compile time? So how many think that if I was to change that method in this, and I downloaded the dependency with this in it, I haven't changed my code, but the dependency has changed, would that run? Who thinks that will fail to run when I try to access this method? Who thinks, okay, who thinks it's going to work at runtime? Who thinks it's going to fail at runtime? Oh, that's good. Okay, what about compile time? Who thinks it's going to work when you compile it, recompile? Okay, so you'll think it's all going to fail. That's good. Right, and the answer is, of course, yes. The method is not accessible. The VM enforces that and says, I found the method, but it's got the wrong access control, so you can't use it. Excellent. Compile time, well, it sort of depends. And there are reasons why it depends, but we'll carry on because I've got more. I want to get your attention into this. Okay. How about changing the return type? Okay. So again, version 1, you compiled against. Version 2 has come down. You've got a binary version. So what am I asking you? I'm saying to you, if you compiled your code against the first one, but you ran it against this second one, what would happen? Would it fail at runtime? Who thinks it will fail at runtime? This is good. You didn't realize you're going to be tested. Okay. Who thinks it fails at compile time? Okay, cool. You're getting the hang of this. Okay, well, the answer is it will fail at runtime. It may fail at compile time depending on whether the compiler can figure out what the type difference is and deal with it, right? Because it obviously can coerce types when it compiles. So it may work at compile time. It doesn't work at runtime because the signature of the method has changed. So there are two different things, right? There's what the compiler does, and then at runtime, it's what the JVM does. The JVM is just looking for a method that's got that signature because that's what you're calling, right? It doesn't really matter, sort of doesn't matter where it finds it, right? So it can't find it because you've changed it. Okay, so how about if it was an object? So this one returns an integer. The second one has expanded it to return a number. Is that going to work at runtime? Okay, no. Is it going to work at compile time? Yeah, well, yeah, same thing, right? Because the signature is changing. There's no polymorphism here. There's no magic. That signature is exactly the thing that your code is looking for. And if the dependency changes it, you break, mostly. Okay? Right. What about hierarchies? I've got an object in version 1 that extends calculator. In the version, I get rid of that extension. So what does your code do? Does your code work or not work, depending on whether it uses that version or that version? It depends, yes. And there we go. It depends, right? So you can see where this is going. It depends whether or not the compiler can deal with the problem. And at runtime, it depends whether this thing contains all the methods that your code wants to use. Not even all the methods this thing had originally, just the methods that you provide. The JVM loads classes and it's got stuff. It's only when somebody else calls it does it try and find it's there, right? So the hierarchy thing, the model you have in your head for Java is mostly from a compile point of view. Okay. What about exceptions? So I have a class here that throws IO exception, or two methods, not very useful methods, but there we go. One throws IO exception, one throws file not found. Flip them around. File not found and IO exception are the same object tree, the same class hierarchy. Does that work? Does it work at runtime? You're right, not sure now. Okay, so the answer is yes, it works at runtime. Because, I think I have a slide in a sec, we'll talk about it in a sec. And it works at compile time, again, if the compiler can deal with it. It just depends, right? Right, so, now, what happens, where am I with this? Oh yeah, so at compile time, you only catch what is thrown. The compiler just checks to see things are thrown, right? You know that, you have checked exceptions, okay? If I take this method and I replace the exception with something completely random, no such method exception, and I run it, will it work at runtime? Will it work at compile time? See, this is good. Somebody's giving me the right answers. Okay, and there's the answer. Yes, it works at runtime, but no, it doesn't work at compile time, because at compile time, your code is expecting that, and now you recompile and it's like, hey, it's a different method, so it's going to break. Yeah. It works at compile time. Have I got another one? Yeah. Yeah, so it's a compile time construct. The fact that it throws something is for the compiler. At the runtime, it's all about what method got run. I've got a better picture than that one. So when exceptions get thrown, the VM just basically goes up the call stack trying to find somebody who says they'll catch it. The checked acceptance, not checked acceptance, that's a compile time thing. So at runtime, you can throw, well, you know this, you can throw any exception, right? And that's what happens. So from a VM point of view, your code goes, I'm throwing a no such method exception or whatever. It goes, fine, I'll find somebody who'll catch it, and if not, I will terminate, right? Whereas your compiler tries to enforce some pretty rules. Okay. I got one more. Yes. Okay. I have one class called constants, and it has a public static final string called hello world. And I have a second one that's where it's changed it to goodbye world for no particular reason. Here's my user code, and it says print out the value of constants.myConstant. Who thinks that this code, compiled against that, run against that, who thinks this code is going to print out the first hello world? Cool. Who thinks it's going to print out the second goodbye world? Oh, look, okay. It will print out the first one because the compiler inlines that so that that test, this, isn't compiled the way you think it is. It isn't compiled into a call to constants to get the value. It goes, oh no, I know what the answer is because it's one of these. I've cached it in your code. Did you know it did that? Obviously not. That's pretty nasty, but that was there for very early performance reasons. Okay, these things bite you.
Is that also true for any other object than string?
Yeah, it's primitives and strings. Yeah. So it's fun, right? Okay. So what else breaks us? We got loads to do and I haven't got time. Okay. So quite often the fact that you use IDEs hides a lot of this because you use refactoring. And if all your tests are in the same workspace and you refactor things, the IDE will probably go and refactor your tests as well. So you can quite easily bite your downstream users because you've changed things not realizing that it's going to break code, okay? That's really up to you. Unit tests are probably the right thing to do, but if you haven't got integration tests, you need integration tests and you don't refactor them. Right at the end of this, we'll talk about how to test some of this stuff. Right. So where am I going next? Okay, so I have an interface with a method, and I have a class with another method. Okay, where are we? So API music. Okay. Oh, that's right. Yes. Okay. So I have an interface, and you can see it doesn't do anything particularly. And now I want to add a default method, which you can do to interfaces, to provide that facility if the implementer of the interface doesn't use it, doesn't have it, right? So the idea is to stop breaking downstream people when you add things to an interface because you provide them with a default method to run, which is a cool idea. Okay, so you've got your API and your user code. The user code is implementing the obvious missing method, and this default works. Looks good, okay? There is a problem. What happens if the code, the user code that's implemented your interface, has also added its own methods? And what happens if that method matches the name of the thing that you've created? Okay? So, you have interface I1. You have this foo which implemented it, and you have a default method there, and you have a variant of this that existed already. So when you get version 2 of this, and you run against this code, or you can see how you mix it, is this going to work at runtime? Okay. What about compile time? Okay. You're all going, I don't know. Okay. Right. Well, it's a mix, right? It will run because the VM, assuming this method is being used inside this class, the VM will go, I'm looking for a method that's called this. I found it. I care. That's fine. It doesn't, the fact that there's actually another one in there, right, it doesn't matter. It's found the one it wants, it runs, okay? But it won't compile because in this instance, we've reduced the access, right? And the compiler will go mismatch, right? This is what it should be. You've tried to reduce it, so this will fail. So here's an example, a really good example of where, through really good, people will try and help you, but it can break you, right? And so this leads into a real problem that we have with the way that Java works and the way that we write Java a lot is whatever method class you create, whatever public, if you make it final, it's different, but if you make it just a public class and you have methods, that's your namespace. Those methods are all that you can have, right? Because anything you add could clash with people extending you, right? Whatever happens, I could add, if I wanted to extend this to add, like get Z, I've got one here. Hey, I clash this. Whatever I add, I run the risk. My API space is mine, those two methods. I have no way of adding more without potentially breaking somebody downstream. Java's cool, isn't it? No. Yeah. So I think you begin to see how some of this works. Right. So we make poor choices, not necessarily because we realize it, sometimes because the compiler hides it, and sometimes also because we just think we misunderstand how compiler and runtime works, okay? If you don't understand these things, if you don't go out and try this and play with this stuff and just try it out, you may easily find that you break things because you weren't well enough informed. So much as I know a lot of you will be going, hey, I'm changing the API because that's what our customers want, we're trying to do the right thing. You need to think about how you test it. And again, we'll talk about that at the end. Okay, so there are a whole bunch of other reasons that people come up with, and mostly it's about the fact that the design changes. So the solid stuff is all great when you've got a static application, but as you start to evolve it, it starts to get really complicated because of some of these things. So look, there's a whole bunch of stuff. We're going to go through some of these things, but when you talk to people about things, you know what happens? You talk to whoever's commissioning the system, and you go, okay, so what about this thing? And they say it's only ever going to be true or false. And then tomorrow they go, well, we changed our mind, right? So, okay. So there are things like, hey, I was told this was going to it's going to have 10 records. That's the maximum we're going to have. And then somebody says, well, actually, we're going to put 1 billion in. And you go, I made the wrong choice. Right? So what do you do? Right? Well, you could change it to something bigger, but that's not optimal. Try hard not to use primitives unless they're specifically for what they are. So if you're using a number, arithmetic, index, lookup, stuff like that, cool, right? It's nothing else. That's a bad choice. A better choice is to create classes, enums, whatever, that you can use in more informed way. Java is strongly typed. Use it. Every time you drop into a primitive as something, you lose the power, right? And it gives you more flexibility in the future rather than going, okay, I've got to move from a short to a long. Okay, now we need to do a big integer or something. It's like use the tools that are available to you. Right? Arrays getting too big. Again, there's hey, we're going to list, I don't know, we're going to list all the countries in the world, 180 countries or whatever it is, and so the array is this big. And you go, oh, that's cool, okay. Now we want to expand it to list all the countries and all their subdivisions and things. Okay, now it's a lot bigger, right? And suddenly things don't work, right? You have performance issues, right? So that's another common one where you go, the arrays get too big. You run out of memory, things get slow because you're moving around. Why would you do that? Right? You've got streaming. One of the best things added to Java to help you design new APIs is the streaming. Streaming is a new model. Streaming takes you out of the old OO models that we've got. It's much more optimal. You can do a lot more with that, right? One of the things it helps us do is start to reduce this thing, what I call participation, where a lot of the way that objects were designed, the way that we architected things, was this idea of having methods that users would replace. right? That was a very OO thing in the 80s. It's not Java. OO, yes, we have object-oriented. The object-oriented parts of Java that are there are for you to use wisely within your application and not give them free rein to everybody, right? Because if you allow people to override your stuff, they can participate in your decisions, and often in places you don't want them. So anyway, so streaming is another way of keeping people out, right? It lets them do what they want to do, but in a much more optimal and efficient way. Right. Yeah, I think I just said all this, yeah. If you really, really have to return sets rather than arrays, then make them unmodifiable. In fact, doing this is really dangerous because you're giving data away. Making it unmodifiable means they can't add things into the set, but it doesn't mean they can't play with the objects that are inside the set. And that's not what you want. What you're trying to do is control how things get modified. So every time you give stuff away that's got public methods and things, then you run the risk of things changing, and that will bite you. It means you have to do the debugging when your customer says things aren't working properly. Right. So sets, if you really have to, streams are much better. Okay. Now, this one I've seen so many times when people go, is it alive or dead? Okay, we'll give you a Boolean method. And you go, okay, well, that's cool. And now I need something else. You know. So what do? Well, the answer is you've got enums. Enums let you have choices that you can add to. You can't take them away, of course, because if you remove something from an enum, it's going to break the code. But you can add to it. And you can make choices about whether they're valid or not. And you can add your own checks. So you can say, I could return a status object. And one of the methods is it alive? Right? So the user doesn't have to figure out how to work out the answer, because quite often users go trying to look at your state and going, I don't know. You haven't told me what I need to know. And so I'm going to go looking into your code, trying to figure out how to get the answer I want, like, is this server up? Right? But you can put those choices and tests in a place that's in your control that they can access. And you can modify it. And they can't override it. Right. Now, another one is leaking of somebody else's data. So you're relying on something. Maybe in this case, you've got some print server and it's got a whole bunch of objects, and your user wants to do something with that printer. So you're in control for some reason, and they go, give me the print job, right? And then they do something stupid with it because they go, oh, it's one of these, so I'm just going to do something bad, right? You facilitated that. Right? You just passed through somebody else's data. They can do whatever they want to somebody else's data. Now that may be what you want, but quite often it's not what you want. If you're involved in this conversation with printers, it's for a good reason. And often this gets used as a way of bypassing your control so that they can do what they want. And you want to fix that. So let me introduce you to sealed interfaces. Anybody using sealed interfaces? Oh, look, is it one? Yes. Okay. This is your new best friend. Seriously, you're going to find this really helps. And again, we're almost getting there. So, sealed interfaces say, and you can do sealed classes, but sealed interface, this one says, print job controller permits HP print job controller. This thing implements it. This permits means nobody else can implement this interface. Just the named classes. That's really, really powerful. Okay? So this way, you can provide a controller, right, that's just got the methods that you want to expose. Okay? because now you're in control, and the user can't subvert it, because you're going, no, if there's a print job controller that I'm going to provide for about how to use HP printers, it's going to be my one. I'm not going to give you this random one that I got down. No, I'm going to give you one that's exposes just the things I want. And because I've got it sealed, it can't be played with. It can't be faked, because the only class that can implement that is that one, and that's yours. You own it. Right. Where do we get to? Yeah. If you absolutely still need to have this relationship with somebody else's code, then this get print job, which just says, oh, voila, here's the object, do what you want with it, invert it. Start thinking about how you get your user to tell you about print jobs. Right? So if you're managing, whatever system is you're having the covers that you're trying to manage, if you're leaking their data, because that's what your users want, you shouldn't be doing it as part. The other way, you should invert it and go, okay, you've got a print system, you tell me about the print system. Right? Because that stops these horrible leakages happening, and it's these leakages that cause weird problems, because you're complicit with giving somebody access to something they may or may not need to have. Where else have we got it? Yeah, I think I said this, but the thing is, don't let your users infer state. Don't let them go figuring it out on themselves. Figure out what they need to know and make it clear and available and document it. Because is alive does not always equal not dead. You know, and if you are not careful, you'll have things like this where you have some class, right, that somebody overrides, because then they can get in and do things. Because if they can override a method on something and your code calls that method, you've now given control to them. They can do whatever they do, whatever they want. That's a bad pattern. You do not want to be calling into user code in that sort of way, right? Which is why interfaces and abstract classes and things like that are problematic, because you're calling back in. Right. Yeah, so another thing is methods. Methods getting too complicated. So you start off with a nice method, and then you start going, okay, I need to provide more data. Well, whatever I'm giving back, I've got more selection data coming in. Nothing wrong with that, right? That's the right way to do it. You want people to tell you what they want, and you give it back. But it gets complicated, right? And then you want to validate it and all that sort of stuff. And as we've already seen, you want to add methods to that. You want to add parameters. Well, that's going to change the method signature. So you have another method with a different set of parameters, and then suddenly you've got 50,000 methods for all the combinations. Not what you want. Records. Who's using records? Who's heard of records? See, that's much better. Okay. Records are awesome, right? So look, if you create a record class, right, like page selector, which has all the parameters that you would normally pass, that you want to pass in, you can now have a method that says get data, ignore the void because that's a typo, that says just give me an object, in this case a record. The thing about records is that once they're constructed, the data's final. So even if the data's visible, you can't change it. So it's immutable, right? Which is awesome, okay? So you don't have race conditions where you create an object, put data in, make a call, and then go back to change the object, which affects the person you've just called because they haven't got to read the data and all that sorts of things. Records is like, here's a record of the fields, the data you need, take it. And now you can extend it, okay? So, yeah, record classes. They're easy to create, as it says. You can't throw check exceptions, but you can throw normal exceptions. Obviously, you can add your own methods to them if necessary. They're really easy because you can put validation in here and you know that the data has been created once, it's not going to get changed, you can prove it. Is this what I expect? Does it all do all the combinations that I valid? You know, is it okay? So they are good, as it says, as data fields, but there are some gotchas. So you've got that first line is mostly how you create them. Okay. Can you extend them? Yeah, you can add more constructors as long as they call the original one. So you can see that constructor with 3 parameters calls one with 2. Can you update it? Can you add methods to this class? Well, no. It gets really nasty. So if you want to extend this data record into a V2 version, you can't, because if you try, there's no way of adding that way, right? If you try to do this and just add a second constructor, you've got this Z. See that Z field? Where do I put Z? Okay. The problem is, so this is that record class with the 2 parameters. I can have a constructor with 3, but I've got nowhere to put it because I'm not allowed to create instance fields. So a record is a record is a record, and your ability to modify it is pretty limited. Okay? But that's not a problem, because if you combine these, if you make these interfaces, here, our public sealed interface, page config, okay, permits 2 variations. I now have 2 records, okay, which both implement that interface. And on the object that I want, the method that I created in the first page, which is the one where I want to get the data in, doesn't take the record by name, but just takes the interface. That is you can't spam that, because to spam page config for somebody to create their own object, well, they can't do that because that interface is sealed. So it's completely safe and it's extendable. All you've got to do inside your code is go, which version of page config have I got? I think that's pretty cool. Okay, where do we get to? I'm rapidly running out of time because this is far too much fun. The whole interface abstract class thing, as I said, it's all about control. It was allowing people to participate in your code. And that's not a good way to go because of what they can do inside when they get in there. Okay, right. So what does a modern one look like? Let's put this stuff together. I mean, this is just high level, and I'm sure you can evolve this to stuff, but honestly, you've now got the ability to restrict access to things. So you can start now with a final class, with a public method, a public constructor. Cool. I mean, you can put that, you can have that injected. That's where your API starts. You can have config things. You can have a static method. Those are the sort of basic ways. That's the starting point. Then what comes out of that is an API object, which I can now use. Cool, right? It's not overridable, so it has to be this API. So that will be the entry point, right? It may or may not be a singleton, but in general nowadays the advice is never create a static object, create a singleton, because you never know when you need another instance of it, because that's a common pattern that happens. So if it's really complicated, you build yourself a builder. So you have an API builder, which has a config class inline, and all the configure class does is takes all the data and returns itself, so you can do the .build pattern. Okay, and at some point that configure does a build. You have a configure object, you can validate it, you return the API. Okay, really straightforward way of doing things. Very hard for people to break into because they're just going to do .configure, build, right? And you can do that even for some of these record objects. Like if you have a really complicated object you want to pass in, then builder patterns are really a nice way of doing that. Okay. Yeah, so this mechanism says of having sealed classes and having permitting particular objects lets you lock down the behavior so that you can't be spoofed. So in this case, I've got an interface that permits a data object, okay? Final class, get data, returns a data object. It returns a new instance of that. People can't fake that because the only way for it to happen is inside your code. They can't override your code because it's final. They can't implement the interfaces because they're sealed, right? Everything is hidden behind this interface. And if you do it this way, the interface that you implement in these objects, right, the methods can be as many or as little as you want. You can have a lot more stuff happening in the real object, but you're just exposing the methods you really need. Yes?
Can they still create weird stuff with reflection? Or is that like...
You can always create weird stuff with reflection. I suspect you probably can. Yeah. Okay, I'm really running out of time. What else are we going to say? Well, you know, I bet you nums. Let's move on. Well, other than this, my advice to you is this bit here, right? Right, an int is a number. It's not an account. A string is a label. It's not a zip code. Don't overload the primitives with meaning. Right? Put the meaning somewhere else, and sure, create a label or some other number, but treat them as what they are, and don't go, they mean something else, like they mean points of the compass. You've got other ways of doing that.
Private field zip code.
Sorry?
You have a private zip code. In your if you have a class, you have a field in it.
Yeah, you have, yeah. So you can have the strings inside your classes, but don't use primitives and strings as to represent that object directly. Right? If you're going to represent an object directly, create an object, right? Because how you have a string and it's a zip code, and then you have 50,000 methods to do with strings, which have nothing to do with zip codes, right? Have an object called zip code. You can reason about it. You can move it around, and then strings don't end up in wrong places because you've lost the type safety because you're now using strings. Okay, blah, blah, blah. Yeah, I think we did that one. Final classes. No, non-final classes are bad. Do not let people override your classes. I mean, because they can do bad shit. They can get in there. You call a method, they go do something else, right? That's not what you want to have happen. So try and do streaming, right? Streaming helps you, and try and put the control, the filtering. Sometimes you need the filtering to be given to you, but if you can get them to do streaming, then your user makes choices about what data it wants. Okay, and occasionally, for performance reasons, you may say, you need to give me something, right? And that's unfortunate. Occasion that happens, right? But try not to, because try and make sure that the control is in the right place. Yeah, we did that one. Yeah. This really is a great pattern. I cannot tell you, the code that I write, I try and do this as much as I can. The whole sealed interfaces thing, the idea of giving out objects that which only the methods that I want them to use are available, and mostly that's read time. Okay, it makes such a big difference to be able to do that. And then you've got this, you're not breaking methods signatures if you evolve these data objects. That separation makes a big difference. There we go. It's really cool. I like it. A couple of more things. Sealed classes are really good, except that anything that the permit stuff, you can't use anonymous classes, unfortunately. So you have to have real classes because you've got to name them. It's still worth it. If you want to look at building, because I know we're almost out of time, if you want to look at building this yourself, for my code, just because I'm doing this to prove things, I've got 2 versions of the code in the same place. So I have a Java module, Java with a couple of modules. But basically, if you look here, this is running the Surefire plugin. It does it at package time, which works well. And then you have this class dependency exclude. So what you can actually do is have multiple dependencies with different versions. And at test time, you can flip backwards and forwards about which of these 2 you exclude. Right? So if you have your tests in one module and you have one or more modules, or it's another one that you've deployed, it's easy to take tests and fire them against different modules, different versions, just by using this dependency exclude thing. Right? It's really makes things easy. Yeah, and the other idea is release your tests as a binary so that you can do these things, right? Tooling for checking out APIs, differences. There's this one, is the one we use at Cyanotype. It's okay, for sure, does some cool stuff. There are things that we could do better with this sort of stuff, but there we go. I want to shout out to those people who move the requirement on you from moving from Java 8 to Java 11, but don't change the major version on their code, so that you don't realize that it's a major break. So I really appreciate that. Thank you very much. Okay, and literally within, I'm over the time. Thank you so much. 10 extra. So I'm going to take all the stuff I've said, and I'm trying to turn it into an article. It's going to turn up on FoodJ or somewhere here, so keep your eye out. If you have any interest in helping other developers improve themselves and you have ideas about what they should be taught, please come along and just raise an issue. That's all I'm asking of you. We'll come back at some point and ask you maybe if you want to contribute a few words, but we're trying to build a better bar for developers, and the sort of things I've just told you hopefully will go in there as well. Anyway, thank you very much. Oh, and I've got stickers. Yeah.